Okay, here's the deal. 5-3 and 5-4 is partially the drawings that you're doing right now, okay? That is the constructions you need to be able to do. Angle bisectors get you the incenter, perpendicular bisectors get you the circumcenter. They're all listed at the end of that worksheet, okay? What we're gonna do now is using those things, but applying them to different triangles, okay? So first of all, we need to talk points of concurrency. What is a point of concurrency?
That's
where the lines meet. So in a triangle, if I draw the 3 angle bisectors, they all meet at one point. That is a point of concurrency, okay? If I draw the 3 perpendicular bisectors, they all meet at one point. That is a point of concurrency, okay? Here's what we're gonna do with it to apply it on one of these problems. If you have where did my, there we go. Okay, I'm going to show you on a graph if you have a triangle that looks like this. Just watch on this part, okay? If you don't have graph paper, it's fine. Just watch. Okay, let's say you have this triangle. Now think about finding the circumcenter, okay? If I tell you to find the circumcenter, does anyone remember or want to look on that sheet what point of concurrency, what lines do you have to draw to find the circumcenter? The perpendicular bisectors. Okay, so here's the deal. Technically, you have 3 perpendicular bisectors because you have 3 sides of a triangle. Do we need all 3? No, you only technically need 2 because they will meet, okay? So if we look at this first side, so look at my blue side here. I want a perpendicular bisector of that side. That is a horizontal line. What's perpendicular to a horizontal line? A vertical line. So I know I'm drawing a vertical line. How do I bisect it? It's 4 units long. 2, right? Cut it in half. So if it's 4 units long, at 2, you're going to draw a vertical line. So that would be our first perpendicular bisector. This is perpendicular. These are the same. Okay? Then you need a second perpendicular bisector. And our second perpendicular bisector, we're going to do, which line makes the most sense to bisect and make perpendicular? The vertical or the slant? The vertical line, right? Because perpendicular to a vertical line is a horizontal line. So I want the perpendicular bisector of this side. Well, it's vertical, so perpendicular is horizontal. It's 6 units long. What is cutting 6 units long in half? 3. So at 3, you're going to draw a horizontal line. Okay, now look at where your blue and your green met up. When they say find the circumcenter, they're saying what is that point? What is that point? 2, 3. Okay, so your answer is the point 2, 3. So a perpendicular bisector meeting a perpendicular bisector, what point do they meet at? Okay, sometimes they don't give you a graph. Oh, sometimes they just give you points, and that works just the same. If you want to graph it, you can graph it, or think about what we just did. Essentially, we found a midpoint of our 2 sides, right? So if think of it this way. The midpoint formula is this. Remember this one? X1 plus X2 divided by 2 and Y1 plus Y2 divided by 2. Okay? That's what we're going to do. We're going to do the midpoint formula with these 3 points. What you'll notice here is your X values. How many different values do you have? 2 different ones, right? There's a 0 and there's a 3. Those are your x1 and your x2. Okay? So we're going to go 0 plus 3 divided by 2. Then look at your y values. How many different values do you have? 2, right? 0 and 2. That's your y values. 0 plus 2 divided by 2. So you can just plug it into midpoint formula and it will get you your point. Okay, 0 plus 3 is 3. 3 divided by 2 is 1.5. 0 plus 2 is 2. 2 divided by 2 is 1. So my circumcenter is that point. Okay, now I could have graphed it and I would have come up with the same thing. So it's kind of up to you. Do you want to graph it? Do you not want to graph it? That's your setup. Okay? If you're going to graph it, you're just plotting those 3 points and doing what we did up top. Yes?
Okay, so how is your 2x values 0? Like your x values, how is it?
So you have 0, 3, and 3, right? You want the 2 that are different. 0 and 3 are your 2 numbers.
Gotcha.
Okay? So you have 3 numbers. You're only using 2 of them. You're using the 2 that are different values. Okay? Okay, then that's from 5.3, okay? From 5.4, that's where we learn about the centroid of a triangle. And the centroid of a triangle is really cool. I wish I had remembered ahead of time to do this because I always like showing my students how this works. A centroid, God bless you, a centroid is the center of gravity for a triangle. So if you were to take a triangle, cut out a triangle on like cardstock, I would do it right now, but on paper it doesn't work because paper's too flimsy. But if you did it on cardstock and you cut the triangle out and you found the centroid, like found the midpoint, drew the line in, found the midpoint, drew the line in, found the midpoint, drew the line in, a triangle like that, if you balance the triangle on the centroid, it balances perfectly. It's the center of gravity for a triangle. It's really cool. Wish I would have done it, but I don't know what I was thinking. I forgot. But here's the thing. Let's say I give you a triangle and we find the centroid. Okay, so we're going to try to make as pretty a triangle as we can here. Okay, if this is my triangle, and I find the midpoint of this side, so these are congruent, that's going to connect for a centroid, that's going to connect to the opposite vertex. Okay, so I'm going to connect to that as best I can anyway. There we go. Okay, so that's one median. Then I'm going to do it to my next side. So find a midpoint here. And I'm just eyeballing this right now. This is not actually calculating, finding it, but you'll get the idea. And then you draw that line in. Okay, and then your third one would be here. Okay, so this point in the middle, that's my centroid. I found 3 medians, I got a centroid, okay? The beautiful thing about a centroid is the parts of the medians are equal proportions of the entire segment. So here's how it works. You have 2 pieces. So like if this is A, B, C, D, E, F, and G, okay? How it works is AD is an entire median. DG is 1/3 of that median, and AG is 2/3 of that median to make 3/3, okay? Then you move to a different one. FG is 1/3 of the median. GC is 2/3 of the median, okay? BG and EG work the same way. 1/3 for the shorter piece, 2/3 for the longer piece. Here's where that comes into play. I'm going to sketch you a really, not cute triangle now because it takes too long to make them cute. Let's say we have a median, 3 medians to get a centroid here. Okay, you can just use that same triangle if you want. I just don't want it to get super messy so you can't see what I'm doing. That's terrible. Okay, so here's a median, here's a median, and here's a median. And I'll set it up with all the same letters in case you're using the same one. Okay, what if I tell you right now that FG has a length of 4? Okay, so this length right here is 4 units long. That's 1/3 of the whole median. So what would GC be? If this is 1/3 and this is 2/3, you're just doubling, right? So this would be 8. Okay, pick another one. What if I tell you EG is 6? Okay, is that the 2/3 portion or the 1/3 portion? That's the 2/3. So that one has been doubled to make it 6, which means GB is what? 3, half of that. Okay, but what if I tell you AD? What if I tell you the whole thing? So the whole thing here, AD, is, let me try to make this somewhat to scale. We'll say it's 6. Okay, if AD is 6, can you tell me AG and DG? Right, you have to divide by 3 because it's thirds, right? It's thirds of our segment. So if I have 6, if I divide by 3, that means 1/3 of my segment is 2. So is that DG or AG? DG, it's the smaller one, right? So this is 2, making AG what? 4 to add up to 6, okay? So 1/3, 2/3. So if I give you the whole thing, you need to divide by 3. If I give you the longer portion, you cut it in half. If I give you the shorter portion, you double it. Does that make sense? Okay. I'll show you after I do this next thing, okay? Okay, last thing is just comparing all the things we've done today. I'm just going to draw you a real big triangle. All right, tell me what this is. Based on the markings I give you, what is this? It is an angle bisector. Okay, so my black line, I'm going to do a different color for each thing. My black line here is an angle bisector. It cuts the angle in half, has 2 congruent parts. Okay, what if instead I went like this? Okay, my red dot is a midpoint, and it's going to connect to this vertex. What is that one? Of the ones we did today, the 4. That's the median. Okay, so red would be a median because it's the midpoint of a side to the opposite vertex. What if I went perpendicular? Oh, that's terrible. Let's see if I can. Okay, what if I went perpendicular through the midpoint? What's that one? It's perpendicular and it's cutting it in half. That's perpendicular bisector. Okay, and the last one, if I go from the vertex perpendicular down, what is that? That one's altitude, right? Okay, so those are the 4 things that you're constructing on that worksheet. You should be able to identify which is which based on its features, okay? I think the chances of you having a quiz tomorrow are like 2%. So don't worry about a quiz for tomorrow. What we'll probably do is kind of take a group quiz that won't count for quiz status, just to make sure that you're getting it, because then you'll see it for the test, but at least have had another time of doing it. Yeah, Michael.